Hello and welcome. I'm Greg Johnston. I'm a geophysicist and have been with Sensors and Software for 24 years. Today I'll be talking about the Echo Project software, and specifically about the SliceView module for processing GPR data collected in a grid and displaying it as a series of depth slices. During the webinar, I will not be able to hear you, but you can type in questions at any time, and I will try to answer those. I think the first thing I need to talk about is the motivation for collecting GPR data in grids. Over the years, even though we strongly preach about the benefits of collecting GPR data in grids, I've found that there's a general reluctance to collect grids. I don't want to think that it's laziness, because yes, it might take longer in the field. But what I've found is that there's a general reluctance for people to collect data in grids. And I think part of it is that people have a hard time setting up a large grid and making sure the corners are right angles. The key is to remember Pythagorean theorem, which is c squared equals a squared plus b squared. But I admit that this is not top of mind for most people. Remembering that any triangle that is 3 units by 4 units by 5 units forms a right angle helps most people to get started. The easiest way just might be our cheat sheet document on how to set up grids. And so if you look, I've attached a PDF of how to set up a grid. And so if you look under the handout option on your screen, you can download that PDF and have it available at any time. Now, since you're attending this webinar, you are likely converts to grid collection. But just in case there are some skeptics, permit me a minute to talk about the benefits. Grids allow you to look at GPR data as a depth slice, and this is a powerful and natural way to understand the information that GPR provides. People are generally not used to looking at cross sections, but they are used to seeing maps. Think about our modern day reliance on Google Maps. The ability to see GPR responses as depth slices allows users to see the spatial relationship of subsurface targets. This can make interpretation much easier, as targets of interest are more easily differentiated from targets of no interest. For example, responses from utilities tend to produce linear targets, while local targets like a small piece of metal or an ancient artifact often appear as point targets. So utility locators are interested in linear targets, and forensic investigators and archaeologists might be interested in point targets. Depth slices provide this information faster and better than any other method. I'm sure that most of you, like me, have spent time in the field with your GPR chasing hyperbolic responses. Oh, I see a hyperbola here. It looks like a utility going this way. Wait, why don't I see another one over here? Okay, here's another hyperbola. Is that the same object as I see over here? This type of random line data collection, doing this, it's easy to get confused, frustrated, and generally do a poor job of understanding the objects in the subsurface at the site. So let's look at a data example that illustrates how grids help to unravel the mystery, and along the way, learn how to use the SliceView module in the Echo Project software. I'm not going to go into a lot of detail about the Echo Project software. That has been covered in other webinars. Recordings of which are available on our website and on YouTube. So let me open up Echo Project. All right, and let's get into the data. So I'm going to open up some new data. So the first screen you see is the Getting Started screen, which asks you, how are you going to open up your data? Well, in this case, we're looking at grids. And there's 2 ways of opening grid data. I can click on the bottom here for the Add Grid option. This is used for grids collected with older Sensors and Software GPR systems. And these are the ones that output data as GFP and DT1 files. And typically these are systems that date before 2012 or so. But since 2012, most of our systems output data to a project file called a GPZ file or a GPZ file. If you have one of these systems, you can use the top 2 buttons to select the GPZ file. At this point, I'll open up a new GPZ file that contains Noggin 250 grid data collected with GPS. So I'm opening the GPZ file, and Echo Project opens up. So this is the main screen of Echo Project. Over on the left, you can see the Project Explorer window. This is the window that lists all the lines. So in this case, we see a folder of grid data, and we can see all the lines, the X and Y lines in that grid. Now I want you to notice that when I select a line in the Project Explorer, it immediately appears in the line preview window over here on the right-hand side. And as I move from line to line, you'll actually see the line preview instantly update with the image of the new line. Now, I want you to look at this line in the line preview. This is data from this particular site. Notice all the hyperbolas. Notice hyperbolas here and here and here and here, all different depths, different shapes, different strengths. It's very complicated. And looking at it on a single line, it's difficult to interpret. Is this a hyperbola that's part of a linear feature, or is it just a point target? So when I move over 2 feet, so if I move over the line to the very next line, you see that some of the hyperbolas linger, but other ones disappear. So I hope that you can see that it would be very difficult to understand what's going on in this site just by looking at cross-sectional lines and putting marks on the ground where you see hyperbolas. Now the other window here is called the MapView, and the MapView window shows the data in a bird's eye view. In this case, it shows the grid, and it shows all the grid lines. Now, superimposed on there are green GPS lines. Now, I'm going to use the layer view window over here to turn off some of the features so it's not so complicated to look at. So I'm going to turn off the GPS lines, and there, that simplifies it a lot more. Okay. Now, I want you to notice that the GPR line currently selected, so I have X line 42 collected in Project Explorer, and I see a red line on the grid. Well, that's indicating the grid line that's X line 42, and of course X line 42 is visible in the line preview on the right there. Now, you'll notice that there are 2 markers displayed, and if you zoom in, you can actually see this says F6 and F1. And we see those same markers displayed in the bottom here. So you can see F6 displayed on the bottom of the image in line preview. So these are fiducials or flags, and they're a marker added to the data by pressing a button during data collection. And all our GPR systems have the ability to do this. Basically, flags indicate something encountered during the survey that the operator wanted to mark, so that when we are looking at the data later back in the office, just like what we're doing now, we will have a closer look at them. Flags are added to GPR data for a wide variety of reasons. They might indicate a target or a change in surface material, such as the GPR survey line moving from a grassy surface to asphalt, or perhaps an object on or above the surface. In this case, when we plot X line 42 and look at the position of the flags in line preview, we see that they correspond to a very shallow hyperbola here at the very top. Likely something on the surface, perhaps a manhole cover or something like that. Now, because this data was collected with a GPS connected to the GPR system, as I move the mouse cursor around the MapView window, the latitude and longitude and the UTM coordinates of the mouse cursor in the project are displayed on the status bar on the bottom of the screen. So if you look at the very bottom of the screen, you can see the numbers changing, latitude 47 and longitude 117 or so. So everywhere I move my mouse cursor, that gets updated because the entire grid has been geo-referenced. Now let's get to SliceView, which is the main topic of this webinar. So back in Project Explorer, I want you to notice that if I scroll up here, you can see that we have a grid folder, and a grid folder has a little symbol on it, has a little grid symbol on it. And the significance of this is that only data collected in a grid can be opened in the SliceView module. So let's do that now. There are several ways to open a GPR grid folder in the SliceView module. One way is I can select the folder, so I can select it here, and then I can click the SliceView button on the toolbar. Or I could select the grid and I could go under Tools and select SliceView from the menu. I could also right-click on the folder name and I could pick SliceView from the menu that opens up. But I think that the simplest way to open SliceView and most intuitive is simply to double-click. So when I double-click on the folder name, SliceView opens. And you'll see that SliceView opens with two windows, one displaying a GPR cross-sectional line, and the other one displaying grid lines and the top depth slice. So I'm going to maximize this, and I'm going to use these two buttons here. I can vertically or horizontally tile the screen. So I tend to, like when I'm looking at this, I tend to tile them vertically. So I get a large screen here. And I'm just going to turn a couple things on here. Okay, and I'm going to make some adjustments so that our experience here is a good one here. Just hold on, it's got to do some processing. And bingo. Okay, so I got things set up the way that I want here. Okay. So let's discuss this window over here, which is the depth slice window. So there's one more thing I need to do. Bear with me a sec here. Here we go. Okay. Let's discuss the depth slice window. This is a map image or a bird's eye view of the GPR grid data. Notice that the GPR grid lines are displayed in this window. The X lines are the horizontal lines parallel to the X-axis, and the Y lines are the vertical lines parallel to the Y-axis. The blue image behind the grid lines is a depth slice, and I will talk more about this in a minute. Now, beside the depth slice is the legend. And so this contains information about the depth slice, including the depth range of the current depth slice. So we can see that our depth slice here is from 0 to 0.33 feet. Okay. I actually like to turn the legend off so that I can make the depth slice larger. You can toggle the legend on and off by clicking on the legend button on the toolbar. And that's this one with the green L on it. So when I click on that, the legend disappears and I have more real estate for my depth slice image. Now let's look at the other window. The other window over here shows one of the GPR grid lines. This line is indicated in red on the window over here, on the depth slice window. Now it's the very first line at the bottom here, so it's hard to see the red, but if I move it over to this one, now hopefully you see the red line here. And so this red line corresponds with this GPR cross-section. Now you can change the grid line displayed in this window in several ways. On the grid lines on the depth slice, you can use the mouse cursor to simply click on it. So if I click on a different line, this window updates with that line. You can also use, there's some, on the toolbar, there's these left, right, up, and down buttons. And if I click any of those, it will move, the line will move one. It'll move to the adjacent line, up or down or left or right. So this is really handy for looking at lines beside one another. You can also use the arrow keys on your keyboard. So if I click on the up arrow, you can see the line moving from line to line to line. So this allows us to navigate through the lines very quickly. Now, when we move through the lines very quickly, it allows us to kind of animate the images. And so if you look at the cross-sectional image, if I do this kind of rapid fire, you can look from line to line to line and look for changes. And this is an excellent way to just look for variations or things of interest in your grid. Now, we can also see features that linger in the same spot for several lines that we know must be linear targets. So for example, if I move to line X31, and the way to tell this, if you look on the top, it'll actually give you the line number here. So I'm on X19, X28, 29, 30, 31. Okay, this is the one I wanted to be on. And what I want you to notice is there's a couple hyperbolas here. See the double hyperbola in about here? Now, if I move to the adjacent line, the one below it, there they are again. I see them again. And I see them a third time. And I see them a fourth time. So I've seen those hyperbolas on 4 lines, 4 adjacent lines at least. And so we know that if we see something on several lines, that this will form a linear response in our depth slice. So after looking at a few of the grid lines, you may want to change the gain. I look at this and I think this is undergained a little bit. So there are tools on the toolbar for doing that. The first thing I'm going to do is click on the window to give it the focus. And because I want to change the gain for the line, I'm going to click on the line image so that one has the focus. Now I look at these three windows. These are these three buttons on the toolbar. These are the buttons that are involved in gain. And right now you can see that this line is auto-gained. And auto-gain attempts to automatically gain the data, but it does not always do a perfect job. In this case, as I said, I think the line is a little bit undergained and it needs a bit more gain. So use the drop-down on the side to switch from an auto-gain to a numbered gain. So I'm going to switch to number 1. And when we look at 1, it looks even weaker, so that's not so good. But the two other buttons for the gain come into play now. Now I can hit plus gain, and I can gradually increase the gain by clicking on it continuously. And so I think that 6 probably makes the data look the best. Now I'm at 8, I think that's overgain. So I'm going to hit the minus gain, bring it down to 6. I think 6 makes this data look the best. Now notice the two red lines on the line image here. These lines indicate the depth range and the thickness of the depth slice displayed over here in the depth slice window. In this case, the depth slice is dominated by blue over here. But what it is that is all the GPR signals between the red lines, but on all the GPR lines in the grid. The red lines go, in this case, from 0 to 0.33 feet. So the depth slice is all the data in the first 4 inches. So 1/3 of a foot is about 4 inches. And so this is a map of all the data in the first 4 inches. Now, to move to the next depth slice, so we want to go to the one from 4 to 8 inches, that is 1/3 of a foot to 2/3 of a foot, roll the mouse wheel, or click on this button on the toolbar that says Move Slice Down. So when I go down to the next slice, notice that the red lines move as well. The red lines, these two red lines on the line image, are moving downward. Again, that indicates the depth range of the current depth slice. Now, another way of moving to a new depth slice is to click on any point in the other window. So if I'm looking at the cross section and I just click, it will instantly jump. The depth slice image will instantly jump to that level. So anywhere I click on the line, I get the corresponding depth slice. Okay, so there's several ways of moving around, moving up and down and around the depth slices. Now, at this point, I should point out that a depth slice is a map. It's a map image of GPR amplitudes or signal strength at that level. For example, if I look at the map from 2.3, so if I look at this map here, so this is saying the depth slice is basically from about 2.33 to 2.66 feet. Now, again, I look at this and I'm not really happy with the gain. So we might want to change it. And so we do exactly the same thing that we did for the GPR line. We're going to use these same 3 buttons that we used before. But in this case, I have to make sure that the depth slice window has the focus. So I click on it to select it. And now you'll see that it's using an auto gain. So the auto gain here is not necessarily doing the best job. We do see some features of interest, but I do want to increase that. So I'm going to switch it from auto to numbered. And you see that this is a fairly large data set. And so every time I click this button to increase the gain, it has to process every single line and apply the new gain to it. So it takes, with a large grid, this can take a little bit of time. So I'm going to skip right down to what I sort of predetermined, that a gain of 8 on the depth slice is what I think makes things look best. Okay, so now you can see I see a lot more in the depth slice. I see a lot more of these subtle reflectors, which is what I'm after. Now, I want you to also remember the quality of the depth slices is affected by the velocity. For the best, most focused depth slices, make sure that you calibrate for the velocity. Now, I'm sure that most of you know how to do this because it's a feature of all our products. So based on the depth slice and the GPR line images, I'm going to look for a linear target that was crossed at a right angle. And so let me just slice up and down here a little bit and look for, okay, so here's one. If I look here, I can see a linear target that's running across. Let me just see if I can, there we go. So there's a linear target running across. So I'm going to pick one of the lines that crosses that linear target. And let's see. And, oh, not the one, I picked the wrong one by mistake here. Here we go. So here's the one. Now, if I look at the line here, this should be about 85 feet from the beginning of the line. And when I look around 85 feet, oh, sure enough, here's a hyperbola. Okay, so that's the hyperbola I'm going to use to calibrate for velocity. And remember, the reason I did that is because I've now confirmed that it was crossed perpendicularly. And that is the best way of getting an accurate velocity. Now, you can see the hyperbola is a little bit small here. So I'm going to zoom in. And I'm going to use the zoom window button on the toolbar. So I'm going to click on this one. These are the zoom buttons here. There's 4 zoom buttons. I'm going to click on the one that allows me to select an area. So I click on that one, and I'm going to draw a box around this hyperbola. It's kind of zoom in. So now I can see that hyperbola a lot better than I could before. And now I'm going to click on the hyperbola velocity calibration button on the toolbar. And this is the second button from the left, and it shows a picture of a hyperbola. So what this does is when I click on this, it superimposes a dynamic red hyperbola on the image. And what I'm going to do is I'm going to click on the top of the hyperbola, and then I'm going to grab the tails here, and I'm going to change the shape. And what I'm trying to do is match the shape of that hyperbola, because I know that that hyperbola gives me a good velocity. Okay, so now I've done the best shape here. You realize I'm not necessarily picking the highest band. I'm picking the most complete band that I can find with the longest tails. And I think I've done a pretty good job here. And if you look, it says the velocity is around 0.328. So our velocity was off before. And so now the data is going to be improved by using the correct velocity. So to apply this new velocity, I'm going to click on the same button again, and it's going to ask me this question. Do you want to update the data based on the new velocity? And I'm going to say yes. And it's going to work its way and process the data and redisplay it as depth slices. Okay. So it's working away on it. So what I want you to note now is what should have happened. Now that we have the correct velocity, things should look a bit crisper in our data. Things should look more focused. And that's what you want when you have the correct velocity. All right, so now that we have good gains and an accurate velocity for both the depth slices and the GPR lines, we can really start interpreting the data. Now, it's good practice to move through all the depth slices from top to bottom. So if I start at the very top, so I click up here, I'm just going to scroll through with my mouse wheel and see what appears. Okay, I've got a linear feature running through here. I've got kind of a linear feature running through there, a series of dots that kind of line up. I've got this point target here. I've got a linear feature here. I've got more linear features here. More. Now I'm starting to see more point targets. Linear feature that's running across at an angle down here. Another one that's appearing as I'm just slicing down 4 inches at a time. And every time I slice, something new appears in here. So now I've got this curved image. And then when I get down, I'm getting down to the more interesting, well, to an interesting one. There's this trident-shaped thing down at the bottom. Okay, so what we see is the responses from utilities will tend to produce linear targets, while local targets like rocks and things like that will appear as point targets. And we see both of those in our data. I think that one of the more interesting targets is the one down here, this trident-shaped thing. And if you look at that, I think the interpretation of this is likely an old septic system or something like that, because these three lines tend to come back to this central line, and then you've got one line that's coming out here. So of my limited knowledge of septic systems, I think that that might be a reasonable interpretation. Okay, so let's look at some other things. Understanding the relationship between the depth slice and the GPR line helps to interpret the data efficiently. For example, if you find an interesting feature on a depth slice, click on the nearest grid line and quickly view what caused that feature. For example, on the depth slice, if I look at the depth slice from this one in here, from 2.66 to 3 feet, we see that there's two linear features here. There's two linear features running along. So if I click on one of the lines that goes across those, and I look at this, now this is zoomed in. I forgot to unzoom my window over here, so I'm just going to click on the Fit to Window button to unzoom it. So there we go. And now what I want you to notice is if I look at this line, so these two features are occurring about 10 or 15 feet from the beginning of the line. So we look at the 10 to 15 foot mark, and there's the two hyperbolas that we saw before. And so we can see that they really do form linear features, and they're visible on several lines. So it turns out we were right. All right, you can also work the other way. If you're moving through the grid lines, so say you're using your arrow keys and you're moving through the grid lines and you find something interesting, you can do the same sort of thing. So for example, if I move to line X27, so I'm going to try to get the line, what am I on here? I'm on X35, no, sorry, X27. There's X25, 26, 27. If I look at this line, one of the things that really jumps out at me is this big hyperbolic response that's very shallow. So it's very strong, but it's very shallow. So if I want to know what it looks like in Plan Map, I simply click on it. So I click on it, there's the map. And it turns out that it's this circular feature in here, this bright red circular feature. Now, if I want to know approximately how big that feature is, I can click on the Measure tool. So up here, you can see a little ruler. I can click on the button, and I can click and drag across that feature to measure its distance. And in the bottom left corner, it'll give me a distance. So this thing is somewhere around 7 feet in diameter or so. And so that's, obviously that's going to be interesting information when we're trying to do our interpretation of what this object is. Now, I want to show you another thing that you can do to clean up your data and emphasize hyperbolic responses from objects in the ground. And this is called the background subtraction filter. And I've talked about this on another webinar when we're looking at cross sections, but this filter is also pretty powerful for depth slices. And the background subtraction filter is designed to remove flat-lying reflectors in the GPR data. This is usually a good thing because when we're looking for objects in the ground, like utilities, for example, we are more interested in hyperbolas than flat lines. If we look at, say, line Y40, so what am I at? Line 37, 38, 39, 40. If I look at this line, for example, when you look at the top in the very shallow part, there's a long straight band here that's about 65 feet long running in the data. So far the background subtraction filter, and actually let's look at the depth slice at that same level. So when I look at this, okay, you can see the red line running across here. So this is the line. And I'm slicing right through that flat-lying reflector. And that's what this big kind of greenish yellowish area here, this wedge-shaped thing is. It's a patch because we're slicing through a boundary. And so that's what happens. Whenever you slice through a flat layer, you get a large, strong patch of GPR signal in the depth slice. Now, the background subtraction filter is on. The actual SliceView will default to having the background subtraction filter on. But it defaults to the average of many GPR lines. And we can see that it does not do a great job removing this 65-foot long flat reflector. So what we want to do is make it more effective. We want to change the filter length of the background subtraction filter, and we want to make it shorter. So let's say we want to set it to 10 feet. To change the length of the background subtraction filter, click on the data processing button on the toolbar. This is the very first button on the left, picture of a hammer and a wrench. And when you go to this submenu, you'll see that we've got the background subtraction filter is on, and it's using the total background. So we're going to switch that from the total background to the local background, and we're going to set that value to 10 feet. And what I'm doing here is I'm setting up this filter so that it will remove any flat lying feature in the data that is 10 feet or longer. And so I'm going to press OK, and it's going to take it a minute to process the data and bring it up. And we'll have a look and see what it does. Now this is a fairly large grid, so it's churning through a fair amount of data. So here we go. Now if you look at the cross-sectional image, you can see that the 65-foot flat reflector is now gone. So it has done a good job of filtering that out. But what I also want you to notice is on the depth slice image, that big patch is gone. And in fact, it's done a much better job. We now see this linear feature much more prominently because of that, that patch being gone. So I want you to notice in the cross-section as well that applying a background subtraction filter doesn't affect the hyperbolic responses at all. Hyperbolas are still intact, but everything that's flat lying has been processed out. Okay, so now since we jumped into the data processing dialog here, I want to briefly point out a few other things that you might want to explore when you're using this software. You'll see that there is a slice thickness value, and that is the thickness of our depth slice. Remember, all the data is averaged over a certain thickness. And what happens is this defaults based on the GPR antenna that was used when you collected your grid. So in general, we're going to have thinner slices for higher frequencies and thicker slices for lower frequencies. The slice thickness can be changed, but don't go too much thicker. Don't go too much thicker than the default. Or what happens is strong GPR amplitudes will tend to get averaged out, and you'll end up with lower values, and they may not be as visible in the final depth slices. So don't be thinking I'm going to make a 3-foot thick depth slice. It usually doesn't work out very well. The other thing that people tend to like to do is the overlap. Right now, I am slicing from depth slice to depth slice with no overlap. Some people will put a 50% overlap in there, and what that does is it makes the slices change gradually as you slice down, because there's a 50% overlap from the slice above. The last one I want to point out in here is the slice resolution. And the slice resolution defines the physical size of each pixel in the depth slice. And so in this case, each pixel on this depth slice image is about 0.14 of a foot, which is just, I guess, about a bit more than an inch or so. So every pixel on here is about an inch in size. And yet, I should have pointed this out very early. I apologize for that. This is a pretty large grid. This is a grid that's 100 feet, 115 feet by 100 feet. And it was scanned every 2 feet. So every line is 2 feet apart. So this is a fairly large grid that we're dealing with here. And so the smallest pixel on the screen here is on the order of an inch in size. So when it does the processing, it's processing actually, you can see it here, 840 by 717 samples. And I'm not good enough to do the math on that, but it is many thousands of points that it's processing. And not just at one level, at many levels, because we have several depth slices. Okay, I just wanted to give you a little introduction to this, this dialog box, because there are some useful things in here, and you may want to poke around and explore. All right. When you are interpreting the data, the grid lines are superimposed on the depth slice. And you can see we've been working with these lines the whole time, but there is a way to turn those off. If you click on this button here, the Collected Lines button, it turns off the grid lines, and you get an unobstructed view of the depth slice. And so as we look at this particular data, as we've sliced down and we've looked at various features in this data, and we've looked at the number of linear features and point targets and this sort of thing, I hope you can appreciate and now understand why collecting a grid was really necessary and really the only way of sorting out the subsurface in this area. There's many targets with many shapes at many depths going in many directions. And so real-time paint marks on the surface would never have solved this. As you are reviewing your data, it's important to remember that SliceView displays depth slices based on the GPR amplitude or the signal strength. So this whole time we've been looking at images. The red areas are strong GPR signals. The blue areas are weak GPR signals. The yellow is in between. So in general, on all these depth slices, our eyes are focused on the red things, the strong red features, because those are the stronger GPR responses. Now, there's going to be times when you can see a weak hyperbola or a weak reflector on a grid line so that you know a subsurface object is there, but it may not appear on the depth slice. So one of the things you can do is try increasing the depth slice gain. But if it's still not visible, you may need to look at adding interpretations to the grid lines to show the target in a map view. And interpretations, however, are not the subject of this webinar. Adding interpretations to your GPR data using the interpolation or the interpretation module is going to be the topic of the next webinar that I do. So watch out for your inbox for your invitation to that webinar. Now, here's a little bit of soapbox stuff. Here's a bit of advice when collecting a grid. Remember that SliceView interpolates GPR signals between the survey lines. Good survey practice suggests that lines be as close together as possible, ideally the same spacing as the length of the GPR antenna. For example, if you have a 250 megahertz GPR system, a really good line spacing is 25 centimeters. Or if you have a 1,000 megahertz system, a good line spacing is 5 centimeters. So for best results, the line spacing of your grid should never be more than twice the length of the GPR antenna. So for a 250 megahertz system, never more than 50 centimeters or about 2 feet. This does mean more work and more time out in the field to do the job right. And many of you will be unhappy to hear this. But cutting corners by using a large line spacing results in large holes in the data. And those holes have to be filled in by interpolating data from the adjacent lines. And this can result in depth slices that appear excessively what we call crosshatched due to the interpolation. For example, you can actually see some of the cross-hatching in here, but if I move down to one of the lines here, this is the one I want to show. This shows the idea of making sure your lines are close enough together. Here we can see a series of dots, and your eye can connect those dots and say, oh yeah, there's a linear feature running through there. But imagine if our lines were further apart. We would have individual dots that you may not necessarily have noticed that form a continuous image. And certainly the software can't do that. It's difficult for it to connect these things together. So the point on all this is that widely spaced lines reduce the accuracy of the depth slice images, and in many cases make the data uninterpretable. All right, now once we have the depth slices and the GPR lines displayed the way we want, there are several things that we can do to save the images. There's several ways to make some output from this. And that's these 4 buttons up in here. These are the ones for outputting. So I can print. Obviously, if I have a printer, I can print it out using this button. I can also copy it to the clipboard. And I can copy it and paste it into a Word document or an Excel spreadsheet or something like that. I can also save the image to a graphics image file, a bitmap, a JPEG, this sort of thing. there's another button in here, and this is a new one in our software. It's called Save View, and the Save View button is this green one here. And what it does is it saves the image to the current project file, so to the GPZ file. And this allows you to include the image in the GPR Summary Report. And if you're not familiar with the GPR Summary Report, it is new. It's been since the last version of Echo Project. But what it is, it's a PDF report. And what I'd encourage you to do is if you hop on YouTube or our website, go to the webinar called Using Echo Project Software to Analyze GPR Data for Buried Utilities. And go to about the 39-minute mark. And this is when I talk about the GPR Summary Report. Okay, now if the grid was collected with GPS, and we know this one was because we saw earlier as we moved around on the depth slice or the grid, we can see the lat long values changing on the bottom edge of the screen. Now, since it was collected with GPS, we can actually save images onto Google Earth. And so to do this, I'm going to go to File, I'm going to go to Export Data, and I'm going to select either all slices or the current slice. So I'm actually going to pick all slices. And what this will do is it will allow me to save a KMZ file, so the Google Earth type of file. It's now going to save all the depth slice images to that KMZ file, and then we're going to launch Google Earth. And so Google Earth, because I have it installed on my computer, Google Earth launches automatically, and it flies to the location where this grid survey was collected. So we zoom in right to this spot here. I'll just kind of, and here's exactly where it was collected. And if you're familiar, I'm not going to get into a lot with Google Earth, but there are different elements here that we can turn on and off. So for example, I'm going to turn off the collected lines because those are kind of mucking up my my depth slice image. So right now, there's a whole series of depth slices. So I can start at the top and I can slice down through and we can see it superimposed in reality. And so there's very interesting features, obviously, in this grid. And when I slice down far enough, I want to see that trident feature there. There we go. So there's what we think might be an old septic system or maybe an active septic system sitting there. Okay. So let me close down Google Earth for a second. Now also under File, Export Data, Slices, there's also options to export the data, the depth slice data, to CSV files or Surfer grid files. So if you'd like to use other software to display them, you can get the data out into a recognized format that you can use with other software. Now, if your grid was not collected with GPS, but you would like to display your depth slices on Google Earth, do not despair, as they say. You can add global positional information to your grid in post-processing. And I'm going to show you how to do this in a few minutes. Now, the last output I want to show is under File, Export Data, we can also save data to a 3D file. And in particular, we save it to an HDF file. And all we have to do is select File, Export Data, 3D. The HDF file format is read by the Voxler software. That's by Golden Software out of Colorado. And Voxler is a 3D visualization software that we sell as an option with the SliceView module. And of course, viewing your GPR data in 3D will be a topic of a future webinar, so not today. So at this point, we're done with SliceView. Hopefully that gives you a bit of a look around on how SliceView works. And so I'm going to shut down SliceView and I'm going to go back to the Echo Project software. Now, you might notice when we do this that the MapView window has changed. The depth slices that we generated in SliceView are now visible in our MapView window. And so if I turn off the grid lines, I go over here to the layer view and I turn off the grid lines, now we can see the depth slices. And I have a slider bar that allows me to slice up and down through the data very quickly. So we can see the features coming and going, we can animate it, and that is pretty cool. All right, but at this point I have to say there is more. There is more. So don't. So I want to show you some other things. So what I'm going to do is I'm going to open another copy of Echo Project, and I'm going to open another project that this time contains multiple grids. So I'm going to go to New, and I'm going to browse for a project. And this is a file that contains 5 grids. So it's going to open it up, and you can see that in the on the left here in the Project Explorer, I've got 5 folders containing grids. So I've got grids 1 to 5, and I've got some random lines collected here. So we can see the 5 grids. So what I'm going to do, there's a bunch of things. There's the GPS lines that I'm going to turn off. I'm going to turn off the grid lines. I'm going to turn off the flags, and I'm going to turn off the interpretations that have been added. And I'm going to use the zoom window to zoom in on these grids so I have a closer look at them. So there's the 5 grids. And the neat feature here is that since we have this depth slice slider bar on here, I can slice through all 5 grids simultaneously. And so if you look closely, there's a nice utility here. So we can see this utility that runs across 2 of the grids. And then when we slice down a little bit deeper, we can actually see another linear feature that crosses all 5 grids. So this is obviously a very powerful way of interpreting multiple grids collected in an area. Okay, the very last thing I'd like to show you today is how to add global positioning information to your grid after the fact. And so again, what I'm going to do is open up a new project that doesn't have GPS with it. So I should point out in this case, these 5 grids are positioned based on the GPS. All right, so these were all collected with GPS, and that's why they're placed automatically in the correct location, or at least the location as accurately as the GPS is. So let me go to a new data set here, and I'm going to open this one called Cemetery, and so you can guess what the data is. But what I want to point out here is, so here's a grid that was collected, and there's no GPS. If I move around the image, you don't see any GPS information on the bottom corner. In fact, you see a message that says the GPS relationship has not been defined. And so what we're going to do is we're going to create that relationship. And so to do that, I'm going to go under Tools, and there's an option called Project Positioning Relationship. And I'm going to pick the wizard. I go into the wizard, and it opens up this dialog box. And what this dialog allows me to position a point in the grid to a global position. So I'm going to work, the first screen gives me the option, am I working in UTM or am I working in lat long? I actually want to work in lat long, so I select that and hit next. Now this is the important screen. This is the one that allows me to correspond a position in the grid with a position on the Earth. And so I'm going to pick the 0, 0 corner, the x equals 0, y equals 0 corner of the grid. And I'm going to tell the program what software or what position that is in lat long. All right, so I've already predefined this, so I'm not just pulling this out of the air. So the longitude on this one is we're west of Greenwich, so it's minus 79.678187. So that's decimal degrees. And the longitude is 43 degrees north, 0.626077. So now, again, I'm corresponding the 0, 0 point of my grid to this lat long, and I hit next. The next screen allows me to rotate the grid in the world. So if you want the grid to point straight north, you would set up an angle of 0 degrees. So I'm gonna do this with the y-axis heading. So straight north would be 0 degrees, but I want to rotate this grid. And so I'm going to rotate it 312 degrees. So, and I hit finish. Now once this is done, I want you to notice as I move through the the MapView window, now lat long numbers are appearing on the bottom edge. And when I double click and I go into SliceView, so this is going to open up in SliceView, and we look at this grid, now for a data set called cemetery, you're not going to be too surprised at the features that we see here. So I'm going to set this up. So when I slice down through, we can see some features that we interpret as being coffins. And so when I have a depth slice like this, and so now what I want to do is show you where this is, where I place this in the world. So again, I go to File, I export the data. I'm going to export all the slices, and I'm going to export them. I'm going to save the KMZ file. It's going to save all the depth slices to the KMZ file. It's then going to launch Google Earth and fly to that spot and show the depth slice there. So we zoom right in, and if I zoom in a bit closer, you're going to see that this is an old church, and it's the graveyard behind the old church, and here are the graves superimposed on there. So again, if you want a slightly clearer image, I'll open this up and I'll turn off the collected lines so that we can see the images there. Okay. So that was the last thing. So that completes today's webinar. So if you need to go, I thank you for attending, and I definitely want to make sure you have a great day.